Okay, so on number 14, we are going to be working with a cube root. So very much like when we have a square root and we square both sides, this time we have a cube root, so I'm going to cube both sides. All right, so if I cube both sides, before I do that, I'm going to move that 2 over to the other side. Forgot about that. All right, so let's move that 2 over to the other side. So that's going to give me that the cube root of 4x minus 3, and this is a plus 2 right here, so I'm going to subtract that over, so that's going to give me is equal to 7. All right, now I'm going to cube both sides. And again, I got a calculator to help me with that. So 7 cubed is going to give me that 4x minus 3 is equal to 343. All right, next I'm going to add over my 3 and then divide by my 4. And that comes out to be a decimal point, so I'm going to use math_frac on that in my calculator, if you can see that right there. So the math button and the number 1 will change that back into a fraction for you, just in case that's what the choice is. So I'm going to do x equals 173 divided by 2. All right, on number 15, I've got another solve the equation here. So let's get everything over onto one side together. I'm going to subtract over my 5x minus 1 is equal to 0. And that's not factorable. I've got 2 and 1. No factors of 2 and 1 are going to subtract to give me 5. So I'm going to use the quadratic formula instead. So let me get my a, b, and c going here. And so my formula for the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4 times a times c. So negative 4 times 2 gives me negative 8. Times negative 1 gives me a plus 8 right there. And then all divided by 2 times a. So 2 times 2 is going to give me 4 on that. All right, so putting that together, that's going to give me 5 plus or minus the square root of 33. And there's no perfect squares that will go into that 33, so I'm just going to leave that as the square root of 33, and that's good enough right there. All right, next on number 16, we're working with finding the domain of a function. So domain is going to be when the denominator cannot be equal to 0. So let me start with that right there. Let's go ahead and factor that. So I'm going to keep my x the way that it is, but then I'm going to factor that as a difference of 2 squares. So that's going to be the square root of x gives me x and x. And the square root of 49 gives me 7. And one of them gets a plus and one of them gets a minus. All right, so I'm going to say then that x cannot be equal to 0, and x plus 7 cannot be equal to 0, and x minus 7 cannot be equal to 0. So that gives me that x cannot be negative 7 and that x cannot be 7. All right, so I'm going to write that in interval notation. Let's just be sure that we get them in order. So if you want to, you can put it on a number line. That may help you with putting them in order. So negative 7, I can't be 0, and can't be 7. But it can be anything other than that. So I could work with an x value anywhere here or here or here or here. So I'm going to write interval notations that represent where the pink parts are. So that's going to go from negative infinity to negative 7, and I'm going to use parentheses on that with my open circle. And that tells me that I can get to negative 7, but I can't actually touch negative 7. Then I'm going to go from negative 7 over to 0. Then I'm going to go from 0 over to 7. And then finally, I'm going to go from 7 up to infinity. So lots of places that I could have an x value on that one. All right, on number 17, I'm working with finding an inverse. Remember, the definition of an inverse is a switching of x and y, so just in case you need that. So the first thing I need is my y value, so I'm going to change this right here into being y equals 8x minus 6 over 15. Okay, so rather than working with f of x is the same thing as y equals. All right, so now to find the inverse, I'm going to switch x and y. So that's going to give me x equals 8y minus 6 divided by 15. All right, now to find the inverse, I'm going to solve for y. So I'm going to start by putting this x over 1, and I'm going to cross multiply. So that's going to give me 15x. And then right here, I'm going to have 8y minus 6. So a good way to kind of get rid of that fraction right there, go ahead and cross multiply with that. All right, so to solve for y, I'm going to add my 6 over here on this side, so 15x plus 6 8y. And then I'm going to divide by my 8 right there. So that's going to give me 15x plus 6 divided by 8. And since both of these things won't divide by 8 or divide by 2 or anything like that, I'm just going to leave that exactly the way that it is. Our notation for an inverse looks like this. Let me go back and write it with the notation. So that'll be 15x plus 6 divided by 8. Okay, on number 18, they're also asking me a domain question. This is a different type of domain. So this one up here was when the denominator cannot be equal to 0. This one right here is working with a square root. And when I'm working with a square root, I'm only worried about what's inside that square root right there. And whatever's inside the square root, I know has to be greater than or equal to 0. Because if I have anything that's negative, that's going to give me an imaginary number. So x is going to be greater than or equal to negative 4. So again, let's look at that on a number line before I go and write that in interval notation. So with a greater than or equal to, I'm going to use a closed circle. And I'm going to be looking at greater than right here. All right, so let's bracket that with negative 4 and infinity like that. Okay, so closed circle gets a bracket. We'll go all the way up to infinity. Infinity always gets parentheses. All right, on this one, I'm working with a piecewise function here. I'm going to highlight this one with green, and then I'm going to highlight this one with pink. So in my green function there, I'm working with values that are greater than 3. So these are your x values right here inside the parentheses. The 3, the 5, the 0, and the 2.7. So I'm going to work with a green function when it's greater than 3, and I'm going to work with this pink function when it's less than or equal to 3. So be sure on these that you only answer with one answer. Don't give two answers. So on A, I'm working with an x value of 3. That's going to fall into my pink category since this is where x's are less than or equal to 3. So that equal to being the important part. So f at 3 is going to be 1 plus 6 times 3, so that's going to give me 18, so that's going to give me 19. Okay, on B, I'm working with f at 0, so f at 0 is going to fall into the pink category as well because 0 is less than 3, so that's going to give me 1 plus 6 times 0, times 0. So that's going to give me 1. 6 times 0 gives me 0. All right, and then I'm working with an x value of 5. 5 is greater than 3, so I'm going to plug it into my green function. So that's going to be 2/5 times 5, which I'm going to let those 5's cancel out, and that's going to leave me with a 2. And then finally, 2.7. I forgot to write down my f at on that last one. 2.7 right here is also going to fall into the pink category because 2.7 is less than 3. So that's going to be 1 plus 6 times 2.7. So 6 times 2.7. 6 times 2.7. Plus 1 in my calculator is going to give me 17.2. So again, the important part about a piecewise function is be sure that you only give one answer per part. Okay, and then finally on number 20, it's talking about a composition to show that they're inverses of each other. So I'm going to find f of g of x. This is a composition right here. I need to make sure that comes out to equal x. And I need to make sure that g of f of x comes out to equal x. So be sure that you show both. All right, so let me start with f of g of x. So f of g is going to be x minus 7 over 2. So now I'm going to take all of this right here, and I'm going to plug it in for x right there. So that's going to give me 2 times x minus 7 over 2, and then plus 7. So I'm going to let these 2's cancel out right here. That's going to leave me with x minus 7 plus 7. So that will leave me just with x. So that one checks out. And then g of f of x. So that's going to be g of, I'm going to plug in 2x plus 7.